Hello everyone, I am Girish P. from Sri Venkateshwara College of Engineering. I am giving the presentation on capillary rise and Bernoulli's equation. Now let's move on the capillary rise. Definition for capillarity. Capillarity is defined as the phenomenon of rise or fall of a liquid of the surface in the small tube related to the adjacent general level of the liquid when the tube is held vertically in the liquid. Next, expression for the capillary rise. Consider a small glass tube of diameter d and its open ends and inserted to a liquid. The liquid will rise in the above the general level of the liquid, where h is the height of the liquid, sigma be the surface tension of the liquid, where theta be the angle of contact between the liquid and the glass tube. The weight of liquid of height h in the tube is equals to density into volume into g, where density is equals to rho into volume is pi d square by 4 into h into specific gravity g is equals to pi d square into rho into h into g divided by 4. The vertical component of the surface of the tensile force is equals to sigma into cos theta into pi d. This is equation number 2. We are equating the equation 1 and 2. Pi d into rho into g into h divided by 4, that is equals to sigma into cos theta into pi d. Where pi d were cancelled, the value of theta between water and clean gas tube is equals to 0. Hence cos theta is equals to 1. Where h is equals to 4 into sigma divided by rho into g into h. Hence the capillary rise is proved. Next, we move on the Bernoulli's equation. Definition of Bernoulli's equation. Euler's equation of motion for a steady flow of an ideal fluid along a streamline in a relationship between a flowing fluid velocity, pressure and density. It is based on Newton's second law of motion, which assumes that linear momentum is preserved without any external forces. Assumptions of Bernoulli's equation. The fluid is ideal, therefore viscosity is zero. The fluid is steady. The fluid is incompressible. The fluid is irrotational. Next, we move on the derivation of Bernoulli's equation. Consider a streamline of in which flowing takes place in the direction of S as shown in the figure. Consider a cylindrical element of cross section dA and the length ds. The force acting on the cylindrical elements are the pressure of P into dA in the direction of flow. The pressure force is P plus del P by del S into ds into dA. It is in opposite to the direction of the flow. Weight of element is P rho into G into dA into ds. Let's theta is the angle between the direction of flow and the line of the action of the weight of element. The resultant force of the fluid element in the direction of S is equals to mass of fluid element into acceleration of the direction of S. The resultant force of the fluid element in the S direction is P into dA minus rho into G into dA into ds cos theta minus P plus del P by del S into ds into dA. That is equals to mass of fluid element is P rho into dA into ds into acceleration of the direction of S is AS, where AS is the acceleration of the direction of S as shown in given by AS is equals to V into del V by del S. Next, the equation P into dA minus rho into G into dA into ds cos theta minus P into dA minus del P by del S ds into dA, that is equals to rho into dA into ds into V into del V by del S. Here P into dA were cancelled. The minus rho into G into dA into ds cos theta minus del P by del S ds into dA, that is equals to rho into dA into ds into V into del V by del S. Here we are dividing the rho into dA into ds on both the sides. minus g into cos theta minus 1 by rho into del p by del s, that is equals to v into del v by del s. Here the left hand sides are will send to the right hand sides, g into cos theta plus 1 by rho into del p by del s plus v into del v by del s, that is equals to 0. From the figure 2, cos theta is equals to dz by ds. Here we substituting the cos theta is equals to dz by ds, g into dz by ds plus 1 by rho into del p by del s plus v into del v by del s, that is equals to 0. Now we are dividing the del s on both the sides, g into dz plus del p by rho plus v into del v, that is equals to 0. Therefore ds is equals to del s. Next, the above equation is the known as Euler's equation of motion. The Bernoulli's equation is obtained from the integration of the Euler's equation of the motion, where integration of g into dz plus integration of del p by rho plus integration of v into del v, that is equals to constant. Here g into g into z plus p by rho plus v square by 2, that is equals to c means constant. Where here we are dividing the g on both the sides, z plus p by rho g plus v square by 2g, that is equals to constant. Here v square by 2g plus p by rho g plus z equals to constant. This is the equation from the Bernoulli's equation, where v square by 2g is equals to kinetic energy per unit weight or kinetic head. P by rho g, that is equals to pressure energy per unit weight of fluid or pressure head. Z is equals to potential energy per unit weight or unit weight of fluid or potential head. Thank you for watching.